Okay. Hello guys. Today you are going to be learning Rust with me. Well, I mean literally with me. And well, we actually have to continue from compound times. So in last night's stream, we actually completed till simple data types. We explored all three, no, four primitive data types. So first one was the integer, scalar types. Yep. So the first one was integer. The second one was floating point types. Third one was the boolean, and fourth one was the character type. So you know, and numeric operations. If, well, the conversions occur in numeric operations, basically. Sorry if I'm feeling a bit tired, but so uh, now that we have done simple data types, okay, the scalar ones, we have compound types. So compound types can group multiple values into one type. Rust has two primitive compound types in tuples and arrays. Okay. So the tuple type. Uh, so if I think if I'm not wrong, if the tuple type is just immutable, I think it could be mutable, but I don't know. Like completely mutable, like a constant. So what we are going to do is, yep. So we are going into the tuple type. A tuple is a general way of grouping together a number of values with a variety of types into one compound type. Tuples have a fixed length. Once declared, they cannot grow or shrink in size. Okay. We create a tuple by writing a comma separated list of values inside parentheses. Yep. That's basically how tuples are written in Python also. Like this. So this parentheses, left bracket, right back bracket. So these are the parentheses. And you have to put in your values separated by commas. Each position in the tuple has a type, and the type of the different values in the tuple don't have to be same. Wow, this is something new. So we'll see. We've added optional type annotations in this example. So let up I32. So this is basically a tuple of three variables, I think, or three values. A tuple of three values with data type. So the first data type of the first value will be signed integer 32-bit, which we covered last time. I32. The second value would be of data type float 64-bit, and the third value will be of type unsigned integer 8-bit. Okay. So this is how a tuple is made. So this is what I'm understanding from this. And let me just try this actually. Okay. Where's my just go over. I could access it from here also. I keep forgetting I have two places to do this. Uh, Secret number. Okay, so we were trying something out right yesterday. So over here, uh, let me just. For now, I'm deleting everything over here because you just guess. So I think it is more or less all right. And wait, I think the final. Sorry. Oh, okay. So what we are going to do is value of. So we are going to assign a tuple. Okay. So if you just give me 1 second. I think I could. Okay, my screen is on the right. Okay, we are good. So what now we are going to do now is let uh, going to do vals. I32 would be there we go. So this is our tuple. So what I did here is I declared a tuple with the name of vals and it would have four values with the data types: floating point 32, floating point 64, signed integer 32 bit, and unsigned integer 32 bit. So here the first one is floating. So see, both of them are floating point, but this would be declared as a 32-bit variable, and this would be declared as a 64-bit variable. So there's that, and here I put 32 because I put I here instead of you. So as we had covered in the last actually last stream, last Rust stream, not this, not the previous stream, just the previous Rust stream, of this series. Uh, well, so over there, the value, see the, since this is 32-bit, so the range would be 2 minus 2 raised to the power 32 to 2 raised to the power 32 minus 1. So that would be the range. So that's why, since it is a signed integer, so I can write a minus. But uh, the one next to it is an unsigned integer, so that's why I didn't put the minus there. Because unsigned integers have a minimum value of 0. Basically, they start from 0 to whatever your number is, 2 raised to the power, I think, 32. I think, yeah, 32. Yes. So stdin guess secret number. So now that we have a tuple, okay. So what we are going to do now? Okay, so we can assign. Oh, nice. So what we are going to do is, let x, sorry, okay. So we did val1, val2, val3 and val4, okay, equal to vals. So that means the four values present here will get assigned to these four. Uh, so the value of val1 would be 3.2, value of val2 would be 6.4, value of val3 would be minus 32, and value of val4 would be 12. Okay. So what we're going to do now is you win. Okay, I'll just write val1. Okay. Oh. How about now? Cannot. Multiply f64 by f32. So we can't do these operations, right? Okay. So okay, I think. So this is what we'll try out. Here. Cannot subtract U32 from I32. Why? Oh shit. Sorry. So okay. Okay. So if I'm taking some time here, I'm trying to show you guys an example. And so now, see, I think an error will come here. Let's see what happens. Okay, there was a warning. So okay, so now what has happened is this. See, overflow, because so what we had to do is put it in here. Now it will get solved. So we'll try again. Let's say I put 64 too small, 75 too big. Okay, sorry, 72 too big, 69. Nice, nice. Yeah, literally nice. Yeah, 69. Huh? Like the random number generator did it. It had no part in it. Since actually changed the you know code back to the original form. That's why. So this is basically what I had to show you. So now these values are you know okay. Just give me a second. I we'll just try again one last time because I need to 836. uh, let's say I put 83 and what the fuck was that? Okay, so we had 3.2, okay, and the first one was so multiplied by 13.2, okay. So we have 3.2 multiplied by 13.2, so 42.24, okay. And then value 2 plus 14.1 is 20.5, yes. And because value 2 is 6.4, value 3 is value 3 divided by 16, which is minus 2. So minus 32 by 16, which is minus 2, okay. And value 4 is not 12 minus 10, which is 2, okay. And it's not value 44, it's value 4. So, yeah. I'll not run it again because we need to go ahead. So, the program first creates a tuple and binds it to the variable tup, which is exactly this. It creates a tuple and binds it to the vals in our example. Okay. Then it uses a. Okay, no, sorry. I went too ahead. Uh, Sorry. The variable tup binds to the entire tuple because a tuple is considered a single compound element. Okay. So this thing is a single compound element within parentheses. For to get the individual values out of a tuple, we can use we can use pattern matching to destructure a tuple value like this. Okay, so that's what we tried out. Okay, uh, yeah, I just saw it with and the program first creates a tuple and binds it to the variable tup. Okay, so actually he did it like this, but we put the annotation just to make everything clear. Otherwise, when you're learning, you tend to get confused. So I kept the annotation as it is. It's better that way. It's actually more understandable. If someone wants to read your code, annotations actually help a lot. So when a new person is reading your code, he knows what value is coming from where and what's the data type, basically. So that's why this annotation is actually important. If I'm not wrong, because I'm just learning. So this basically, I think, general programming. You have to put comments and you have to annotate your code. Basically, you have to add, note the comments, notes. You have to structure it properly. You have to make sure that the code is also readable. Uh, so it uses pattern matching with let to take. Okay, sorry. The program first creates a tuple and binds it to the variable tup. It then uses a pattern with let to take tup and turn it into three separate variables x, y, and z. Okay, this is called destructuring because it breaks the single tuple into three parts. Finally, the program prints the value of y, which is 6.4. Yup, because y is the second value. It maps to this. We can also access a tuple element directly using a period following the index of the value which we want to access. For example, oh, nice. So what this said is that we can, instead of doing this whole thing, we can now like I don't know how to comment, so we'll just undo. don't matter. Okay. And x dot 0. Okay, so this is 0 based, right? And one. There you go. So if I run this again, too small, too small, too small, too big. Okay. So basically, when I replaced uh, those vals with this vals dot 0, so since it follows a zero indexing, like zero based indexing, so this will be vals dot 0, the first element. Um, the second element will be vals dot 1. The third element will be vals dot 2, and the fourth element will be vals dot 3. Since this is a zero based index, so the first element will have the index of 0, n minus 1 basically. So if you want to look at it in that terms, so this is how we do tuples. Okay. This program creates a tuple x and then accesses each element of the tuple using their respective indices. As with most programming languages, the first index in a tuple is 0. Exactly. So this is in most programming languages: C, C++, Java, Python. I think yes, Python also, .NET, C Sharp. No, C Sharp is actually part of .NET. We have Visual Basic also with that kind of. I think I don't know. I think Visual Basic does have. It does it. It does have it. It does have that kind of indexing. And well, we have right now. Okay, the tuple without any values has a special name, unit. This value and its corresponding type are both written exclamation parentheses and represent an empty value or an empty return type. Okay, so this is a unit. Okay, expressions implicitly return the unit value if they don't return any other value. Okay. So okay, the array type. So now that this is done, we'll go ahead with the array type. Uh, Another way to have a collection of multiple values is with an array. Unlike a tuple, every element of an array uh, must have the same type. Unlike arrays in some, okay, unlike arrays in some other languages, arrays in Rust have a fixed length. We write the values within an array as a comma separated list inside square brackets. Okay. So typically, how we write a basic array. Okay. Basically, if I want to write this, okay. I want to see something. Okay. So F64 4. Uh, so now that this is here, okay. So arrays are useful uh, when you want your data allocated on this stack, the same as the other types we have seen so far, rather than the heap. We will discuss the stack and the heap more in chapter 4. Okay, or when you want to ensure you always have a fixed number of elements. Okay, an array isn't as flexible as the vector type. Okay, though a vector is a similar collection type provided by the standard library that is allowed to grow or shrink in size. Okay. So basically, array can't grow and shrink in size. If you're unsure about whether to use an array or a vector, chances are you should use a vector. Chapter 8 discusses vector in more detail. Okay. However, arrays are more useful when you know the number of elements will not need to change. For example, if you were using the names of the month in a program, you would probably use an array rather than a vector because you know it will always contain 12 elements. Okay. Yep. So this is basically static or immutable actually. So these are immutable data types if I'm not wrong. Uh, okay, so he declared let months equal to uh, January to December with the string, all the string data types. Sorry. Oh. Sorry. That felt good actually. And let me just continue with this. Okay. So you write an array's type using square brackets with the type of each element, a semicolon, and then the number of elements in the array, like so. So since you know we are using, so this is basically 5 integers with i32. It could be u32 also because these are positive integers. So the annotation is there are five elements with i32 data type basically in this a array. If this is the simple terms basically. So if I'm going to write a double r is never used. Okay, I don't care. I will use it though. Uh, okay. F64. Okay. Sorry. There we go. F64 4. And the value name is ARR. The array name is ARR. Here I32 is the type of each element, and after the semicolon, the number 5 indicates the and array contains 5 elements. Basically, what I told you. You can also initialize an array to contain the same value for each element by specifying the initial value, followed by a semicolon, and then the length of the array in square brackets as shown here. Okay, just give me a sec. Okay, my mic volumes are okay. I'll just minimize. Okay. Okay. So you can also initialize the array to contain the same value for each element by specifying the initial value followed by a semicolon. Okay, and then the length of the array in square brackets as shown. Oh, nice. So you can just build an array of threes. I want to try this actually. There you go. So basically this will now contain four values of 3.24 each. Accessing array elements. Okay, so over here, sorry. Over here now, so we have accessed an array. So what we are going to do is F64, right? So what we are going to do, since this is F64, this array, we'll just play over here. Okay. No, sorry, no, not R2, A double R. So now I think. Oh, okay, can you just give me a second over here? If I could just put it here and then just a little bit smaller. I think it's okay. Okay, now we are fine. Okay, so now what we have done is we have taken the sum of all four elements over here. And we'll do. Okay, so now we'll input the number. Okay, so this is what happened. What, what is this? Everything was F64, right? So why did this happen? And this is ARR, right? I did use A double R, yes. So this is actually very strange, but well, there you have it. We could actually add it up like this. And what's the time here? 5:56. I started around 8:15. In this, so okay. The array name A will contain 5 elements that will all be set to the value 3 initially. This is the same as writing let A equal to 3.3, but in a more concise way that will. An array is a single chunk of memory of a known fixed size that can be allocated on the stack. You can access the elements of an array using indexing like this. Okay. So let first equal to a0, let second equal to a1. I was actually saw that first and then implemented it here. So you know, and in this example, the variable name first will get to the value 1 because that is the value at index 0 in the array. The variable name second will get 1 from index 1 in the array. Okay, value 2 from index 1. So, yes, 1, 2. Okay, that's basically what we did. Uh, so, a double r 0. So basically what I did is 6.4 over here. Sum of 6.4, then plus 3.2 plus 6.4 minus 32.2 and 12.6. So these all got added. And then we added 14.2, but the problem is 14.1. But the problem is I don't know why this came out to be so. Warning. Achha, warning in this. What's the first warning? How was it not used? Okay. So in the invalid array element access. So basically, if I would try to see, and so this thing, if the invalid element thing, right? I can basically just reproduce it from here only. If I just write 4 instead of 3. See? Index out of bounds. So if I actually want to run this, we'll run this only. I don't care. So it's telling me that the operation will panic at runtime. Okay. Yeah, so it will panic. So that's why you shouldn't put an index, like a wrong index. So in this program, when I run this program, if I use this program, I'm not going to do it. I'm really tired. So basically, what this program is you have an array, okay, and read a you read a number, okay. You are asking the user to enter an array index. The user enters the index, and when you enter the index will get created as a unsigned integer, and then you will declare a variable which is a of so it will access the index will actually come over here. So how do I explain this? So a of basically the element at this index, index, basically the element in this array of this index. So if I put a wrong index, it would panic over here. Basically, if I have 5 and I put, let's say, if I just put 5 as the index here, because since this is a this 0 based, so the last index would be 4 over here. So if I put 5 here, then the program will panic in this example. The code compiles successfully if you run this code using cargo run and enter 0, 1, 2, 3 or 4. The program will print out the corresponding value at that index in the array. If you instead enter a number past the end of the array, such as 10, you see output like this. Thread main panicked at src main rs 1919, index out of bounds. The length is 5 but the index is 10. Okay. So this is what happens. The program resulted in a runtime error at the point of using an invalid value in the indexing operation. Okay, the program exited with an error message and didn't execute the final println statement. When you attempt to access an element using indexing, Rust will check that the index you have specified is less than the array length. Okay. If the index is greater than or equal to the length, Rust will panic. Okay, that's fair. Uh, okay, Rust will panic. Okay, the check has to happen at runtime, especially in this case because the compiler can't possibly know what value a user will enter when they run the code later. That's why, see, that's why when I entered it in the program, before compile time, when I entered a wrong index, the compiler, it just caught that error before I could execute. Like, see, I compiled it with this. Okay, so ARR4. So, and you know, this error got caught at compile time only. Basically, what I'm trying to say here. And okay, when you attempt to access an element using indexing, Rust will check that the index you have specified is okay. So this is an example of Rust's memory safety principles in action. Okay, in many low-level languages, this kind of check is not done, which is true by the way. It doesn't get done, and like I have had cases when I was coding in C or C++, where there used to be I used to convert the memory wrongly or used to assign it wrongly. So the compiler never used to tell me, but it used to break at runtime. And if I do something careless, then it could actually, break the compiler. Not exactly. I think the its system still has safeguards against this type of things, but for example, when you're doing system calls, if those are not handled properly, and in C++, like, you don't actually have this innate information in how to handle it properly. You have to learn it through experience. You have to learn it, you have to learn it through experience basically. And well, this is so anything could cause a break. Sometime, yeah, if you're actually handling system operations, then it could be a huge problem in that. If something breaks there, some memory is not managed or there is a memory overflow or underflow, and you didn't catch it when you were testing and coding it, then it just wreaks havoc on, like computers. And I think this is something also related to, the Microsoft, uh, Windows crashed that update that happened last year. Basically, I think it was something like that that happened due to. Okay, I don't know. I'm not going to talk about that. So yeah, and when so in many level languages, this kind of check is not done, and when you provide an incorrect index, invalid memory can be accessed. Okay, Rust protects you against this kind of error by immediately exiting instead of allowing the memory access and continuing. Okay. Uh, okay. So chapter 9 discuss more of Rust error handling and how you can write readable, safe code that neither panics nor allows invalid memory access. Okay. Functions. How big is functions actually? Should we do functions right now? Statements of expression. I think no. It would actually take some time to do this. So one parameters, statements and expressions. Uh, so I am actually thinking we will go slow. No, I don't know how long my stream has been running for. I could actually check. Give me a second. Okay, it's almost 1 hour now. Okay, so we'll just keep going on. We're still live, huh? So we'll just give it like almost an hour. We can do 1 hour actually. If I get time, I'll do a 2 hour segment um, soon. But we'll see about that. We don't know about. And okay, just we can do one hour. Sorry. uh, so because if I play it on the side, I'll get the feedback. You know, that shouldn't happen. So functions, should we do it? I could cover a bit of it. Functions actually, okay. So functions are prevalent in Rust code. You have you have already seen one of the most important functions of the language, the main function, which is the entry point of many programs. Okay. You've also seen the fn keyword, which allows you to declare new functions. Okay. Uh, and Rust code uses snake case. Okay. This is the first time I've heard this case, huh? Snake case. Just give me a second. I'll put a bit more. I just have to make sure that. Bamale, Bakasava, Bamale, Age, Slava, Ishkavare. Let's just carry. Okay. So, snake case. Okay. Rust code uses snake case as the conventional style for function and variable names, in which all letters are lowercase and underscore separate words. Okay. Here's a program that contains an example function definition. Actually, my mouth is drying up. Let me have some water. Okay. I thought that felt good. So, okay, I'm back. And, okay, here's a program that contains an example function definition. Fn main print hello world. Okay, and another function. Oh no, sorry. Really sorry about that. Print ln another function. Okay, and so I'll just okay. Just give me a second. I'll actually try writing. Sorry. We'll just cover this basic only. I'll actually cover ahead in next stream, like next Rust stream. So I am actually, doing it in alternates. So I do a Rust stream, then I do a gaming stream, then I do a Rust stream. So right now the streams will be a bit alternate. I'm trying to do two things at once, I think. So if I post every day about different things, it should be actually good. Uh, I will get my music setup done. I actually need a good music setup. If my table permits me to have more things on it, because I need music. I'll get a MIDI keyboard and we'll make some music if I want. I also have a guitar. I'll show you my guitar. Well, I won't be able to play it properly, but let's see. Just give me a second. Not now. Just after we do this function thingy, okay? So the function thing shouldn't take too much time. Oh no. Okay, okay. Don't worry. So what we are going to do now, okay, is we can run this function, but we'll do something advanced, which is basically it is explained below here. So we'll do this. Actually, I'll explain it to you in the next session. But right now we'll do this. So what we are going to do is, okay. This is the main function, I think. So now we'll do fn. Um, so what we can do is we can reduce a lot of the main function. Okay. So that would actually be better actually in that case. So what we are going to do is guess none. No. So we don't need a return type right now. What we are going to do is basically U30, not I32, yeah. Just U32. Just let me have, you know. So what we are going to do now is so see, I am actually guessing it will not work as expected. Okay, right now. Uh, Give me a second. Just take out this. We also take this. Put it here. Okay. And what is this? Loop while block. Okay, I know. Okay. Uh, is control R plus. Okay, I'll just do this. Okay. Uh, just do this. We'll just do this now. Okay. So wait, why? Okay. But this is a warning. It's not an error. We'll do it. You know, we'll guess. Then uh, let guess num string. Yes. Okay. So since we now have a function, so we just went a bit ahead. Okay. So we have a function here with the name of guess underscore number. Okay. And it requires a variable. So it requires a unsigned integer variable, which we have as a guess over there, and this means it returns the value type of string. Okay. Then we picked that secret number code and we put it here. Okay. And then here, since it returns string, so we matched actually unnecessary return statement. So you don't. Oh, okay. Let's see. Oh, you can. Oh, that's why it was telling me that error. Huh? Give me a second here. So this. Okay. Uh, so what we are going to do is Okay. No, it should actually, right? Because okay, and okay, give me a second here. Let's see. It's still giving me an error, huh? Must be a string literal. Hmm. Okay, okay, sorry. Uh, what if I just do this? Okay. Hmm. Oh, sorry. How about now? Sorry. Okay. So let's see what happens. We have done this. Okay. Guess the number. Okay, 35. Oh no. Okay, just give me a second here. Uh, okay, shit, we are getting very late. Let me just. And. This. I swear, whoever the fuck that motherfucker was, I'll fucking kill that guy, man. Sorry, yeah. Oh, okay, sorry. Okay, so we are good here. Uh, okay, so we'll try again here. Just a gun. So I'll actually end this stream. But what the what? In constants. Okay. Okay, just give me a second then. Okay, I'll have to do this now. Okay, and here we'll do. Okay, so now this will run. There you go. Oh no. Okay, okay, okay. Oh, no, 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 no. Sorry. the fuck? It should have exited, but it didn't. Okay. So now it would. Okay. So this is what we did. So this is the final explanation. We made a function, okay, named guess number, and we did guess. We had two parameters: guess of type unsigned integer 32 and secret number of type unsigned integer 32 bit. Then we put the its if condition here, and we actually then did it. We then put a pattern matching here. So we'll learn if else. When we'll learn if else, this would be actually, you know, this I would actually optimize this. Okay, so so actually it's been a lot of time now. It's 9:40. I need to actually do some stuff. So I hope you guys enjoyed this stream. I'll be taking my leave right now. So thank you for watching. We'll do well now that we have started Metal Gear Rising Revengeance. We'll actually continue with that in the next stream. So we were doing Sundowner Boss, and for some reason the audio wasn't coming in that stream. I didn't check, but when I checked it later, I found that there wasn't any audio for the game. So in the next stream I'll fix that issue, then I'll come back to you. So thank you guys for watching.